Hello, everyone. In the collective imaginary of our societies, radioactive waste is often connected to inexplicable fears, myths, fiction. However, in reality, the nuclear industry is taking care of its waste with the objective of protecting people and the environment. So through this roundtable, the subject will be approached from various angles: strategic, policy and regulatory, industrial. My name is Elsa Lemaitre, and I will be the moderator for this roundtable, representing the French Young Generation Network in Nuclear. So let me introduce our 5 speakers. Olivier Giraud, you're the Deputy Director of the Decommissioning and Waste Management Division at EDF, which is the French utility, and the head of waste management of this division. And as a nuclear operator, EDF is responsible for the management of the waste it produces. Then we have Daniel Delors, Head of International Relations Department at ANDRA, the French National Agency for Radioactive Waste Management, in charge of long-term radioactive waste management on the French territory. Then we have Jussi Heinonen. So you are the director in charge of regulatory oversight, strategic development at STUC, the Finnish Radiation and Nuclear Safety Authority, and you have a sound background in nuclear waste regulation. Then we have Jarrett Adams. So you are the CEO of Full of Communications, an American communication agency specializing in communication strategies for every facet of the nuclear energy sector, including waste management. And Jean-Michel Romary, you are the Director of Decommissioning and Waste Management at Orano, which is a company specialized in the fuel cycle, the management of spent fuel, and the treatment of ultimate waste produced after reprocessing. So thank you very much for your presence here. So as a start, I have a question for Daniel. What are the fundamental principles of radioactive waste management? And based on your experience and your broad overview, can you present the related international panorama?
Okay. Well, radioactive waste management, it is waste generated during all the nuclear activities, but not only nuclear with electricity production, but from all nuclear activities. Those wastes are quite specific and generate risk for the environment and for the human being. So and they have to be clearly, openly managed in countries. Also, in France, we have France has an agency, a state-owned agency called ANDRA. I'm working for this agency, and we are in charge of the management of all the radioactive waste produced in France. We are operating disposal facilities, and we are preparing we are completing the license application for the deep geological repository. The challenges are really for us as ANDRA. There are long-term management of this radioactive waste. And there is a clear need for a very strong and a very robust cooperation with the people who are generating this kind of waste, the industries. And we have here around the table people that can have can put the topic on the table. So, did I answer to your questions?
Can you give us an international panorama of the status?
Absolutely, absolutely. Well, this is quite specific to our industry. There is an intense, waste management is not just a French issue, it's a global issue. Every country who has nuclear facility, who has to manage waste with radioactive contents, they have to manage this. And there is an intense and very significant international cooperation. And this cooperation is mainly led by 2 international agencies, the IEA, which is located in Vienna, and the IEA group, 173 country members. So, and these country members agreed to have a safe use of the atom and try to raise standard guidance on the way to manage this radioactive waste. And you have also in Paris, you have the NEA, which is part of the OCDE, and there are less members, and there are more focus on deep geological repository aspects. So there is an intense cooperation at an institutional level, but also there are a lot of partnerships, discussion between radioactive waste management agencies to try to cooperate on a topic which we are sharing the difficulties and we are sharing the progress and try to consolidate the way we are doing this all together.
Thank you. So I understand that there is a strong legal framework to define the principles of radioactive waste management and a lot of cooperation. So maybe Jared, as an American, can you give us the situation in North America? And maybe give us some example on the current status of existing interim and long-term storage facility?
Yeah, thank you. So the story of nuclear waste management in the U.S. is kind of a long story. Yucca Mountain, which is in southern Nevada, was designated as the site of a future repository in 1987, and very little progress has been made on that in recent years. Through the early 2000s, there was a fair amount of work done, but then in 2010, under the Obama administration, it effectively stalled. I think one of the main reasons was because of the way the site was chosen and because of the politics around it. As many of you know, the Yucca Mountain Repository is really an effectively designed facility that the U.S. Department of Energy demonstrated that they could contain the waste for about 10,000 years, which is the full length of human recorded history. We know that Stonehenge is about 5,000 BC, and the pyramids of Giza about 4,000 BC. So they really showed that the waste could be effectively maintained. The problem was politics. Politically, it was a non-starter because there was too much local and national opposition to the project. So today it is still there, but I think just yesterday, the Department of Energy announced that they were going to resume what they call consent-based siting, which means that the local and state communities have a say in whether or not a particular community can host a facility, which hopefully will help loosen some of the roadblocks that have held back both Yucca Mountain and then as well as these two interim storage facilities, which one is in New Mexico, one is in western Texas, that are also under development. So it's hoped by DOE that reviving this consent-based siting process will help advance those projects. And just briefly on Canada, Canada I think has been wise in its process because they employed this sort of consent or a collaboration with the potential host communities from the start, what they call with a phased management approach, where they started first with 22 potential communities, consulted with each of them. They're currently at 2 potential choices. One is called Ignace, and then the other one is near Bruce. And so now they're currently between those two potential sites and trying to decide on a final one. So all that to say that throughout the story of the United States and Canada, the consultation with the local communities and potential host communities has been as big a factor as the actual geological or technical merits of the projects. So it's a brief overview.
And maybe can you mention one facility that is in operation today, which is the WIP facility, which is kind of the only facility that is in operation today for long-term storage?
That's right. And so what they call WIP, or the Waste Isolation Pilot Project, has been in operation for a number of years in New Mexico, effectively run, and has demonstrated that deep geological repository is technically effective. I mean, it's shown that a proof of concept. I think one of the benefits is that WIP didn't encounter some of the local opposition that some of these other facilities have done, and I imagine that'll be discussion in some of the potential facilities, in other countries as well.
Thank you. Going back to Europe, maybe Jussi, you can talk about the situation in Finland. It seems that you're way ahead with your deep underground repository at Onkalo site for civilian waste.
Yeah, that's true. I would say in Finland we are progressing well with the disposal facility, and Posiva is progressing well. So Posiva is the implementing company in Finland, similar to Andra in France. And what they are currently doing, that they have already excavated, constructed the disposal facility to the depth of 400 meters or 450 meters. The central part is finished, the access routes, the ramp, the shafts are ready, and now they are right now excavating the disposal tunnels. So they are quite far in the actual progress, and in the surface there is a encapsulation facility that the spent fuel would be encapsulated. They are installing the devices now, so the construction is progressing really well. How we came to the situation, it has been a long journey, like it always is, about maybe 4 decades, starting in late 70s, early 80s. And we have gone through the siting phase, design, safety assessment, safety demonstration phase. Construction is ongoing and now coming to the actual operation phase, which is closing quite fast. And during this journey, there has been, of course, Posiva's several safety demonstrations. Me coming from the regulator, we have been evaluating the safety and having oversight of Posiva's activities all the time. And then there has been the kind of local consent, we call it veto right, the municipality veto right, that has been managed. And then the political decision making, there has been a political decision about the disposal. So, and what's the schedule to move on is that Posiva is planning to submit the operating license application in the end of this year. And then the regulator, we would start review of the application next year, and that is estimated to take about maybe 2 years. But we will see. It depends on about the application quality and so on. But I would say, kind of maybe compared what you said about the US situation, that we have been lucky to have the political will from the beginning and throughout the process. And at the same time, I want to raise that we, from the implementer and regulator side, we have been really committed to move on, and then we have had the courage to make the decision and make the decisions in existing of uncertainties, that there is enough demonstration that we are happy to move on.
Maybe for the people that don't know about your disposal, you can explain a little bit some concepts around it.
So, like I would say every disposal facility or deep geological repository, there is a host formation. In our case, it's crystalline rock. In Finland, we have only crystalline rock, so that's the decision. Then there is canister. Everybody has canister. So in our case, it's copper, cast iron, and canister. In the Finnish and Swedish system, we need to rely quite a lot to the engineered barrier system, because the crystalline rock is more. There is more structures and water conducting structures, for example, compared to the French situation. And then there is, to support or to protect the canister, there is bentonite clay surrounding the canister. So basically, in the depth of 420 meters in disposal holes, you put the canisters and then you surround that with the bentonite, and that's demonstrated to be a safe solution.
Maybe just Daniel, you can present the differences in terms of designing option with the Finnish solution.
Yes, but basically there is no difference on the safety objectives and safety fundamentals. Well, yes, in France we have studied granite and clay, and then we construct a laboratory in clay based on public acceptance. And so we decided at the early stage to go to clay. Well, the main difference is clay is quite has very interesting natural properties. It's low for its low permeability, its ability to capture the radionuclides, some of the radionuclides, to have a self-healing properties, and above that we are in a very stable region. There is no seismicity. The clay layer we are looking for is at 500 meters depth. 140 meters thickness. We have no structures inside this, so it is very previsible. I mean, we can predict, and we can. So we went to this option very early. In 2006, we decided in France that by a law that it will be in Bure, and then from that we are now developing. So we don't need to put too much effort on the tightness of the container, the container of the waste, because the geology will provide this long-term safety to the repository. And our concept is based on the geology, where the Finn and the Swedish concept is more based on the performance of an engineered barrier, and the repository is here to protect this barrier. So there are differences, but one more time, the objective is the same. The license review, the application the review of the license application are very similar. There are strong contact between all these nuclear authority. So concepts are different, but the objective is the same.
Thank you. So we've seen that we need to find a suitable site for such facilities, but we have the issue of not in my backyard problem. So maybe, Jared, we can come back to the necessity of stakeholder involvement, and maybe you can share a bit more your views on this topic.
Thank you. Yeah, it's as I mentioned previously, one of the issues with siting a nuclear waste facility is it's less about the technical merits of the particular project than about the stakeholder perception of the relative risks of the facility. So I think it's incumbent on whether it's a private company or a government agency that's pursuing these to engage early and regularly in the stakeholder engagement. Because without the support, without what they call the social license to construct and operate such a facility, it will never happen. That has proven itself in the United States, and probably will repeat itself with other projects. We've seen it it's the same with a nuclear power facility. You need to ensure that you have that community support. So I think what we're seeing now is that there's a lot of new projects underway. There's the Vogel project in Georgia and SMR demonstrations in many states. That hopefully that'll be a pull that will move some of this momentum so that we can restart these facilities. But again, it has to include a large component of stakeholder engagement, otherwise it won't progress.
And do you feel that public opinion is ready for such discussion and such involvement, especially in the US?
I do, because the recent surveys are showing a rising support for nuclear energy. Some of them are at the highest levels we've seen ever. I think rising concerns about climate change and the effectiveness of nuclear energy to be a solution to climate change is increasing support for nuclear. But I think that we can't allow our approach to managing nuclear waste to be a drag on that growth. And I think one of the issues, too, is that, at least in the United States, the incentives aren't structured in such a way that we're making enough progress on waste. I think we need to not have waste become an impediment to the growth of nuclear energy, because it can be. I mean, because the opponents of nuclear energy say, well, there's no solution to waste. Well, there is. There are multiple proven technical solutions. Our problem is that we don't have the political will or have demonstrated that we can do this. But we know technically we can do it.
Thank you. So I guess we cannot talk about nuclear facilities without talking about nuclear safety. So maybe, Jussi, can you explain a bit more how nuclear safety is implemented in nuclear waste management, and particularly on such disposal facility projects?
Yeah, this is going to be a long story, long answer. But to keep it short, what was we already discussed about the different roles that for quite often for disposal facilities, repositories, the concept is same. You have the host rock, you have some kind of engineered barrier system that can be a little bit different, and then those are the two things. And then you have the spent fuel or high-level waste, or so you have the inventory, what you are kind of protecting or sealing. So you need to have understanding of the site, you need to have understanding of the engineered barrier system. In a way, you need to understand the kind of different features, what's happening in the geological environment, how the materials are performing, and then it's kind of assessment that you are making performance assessment for the different parts and then evaluating. Then you are assuming that the radionuclides are releasing, and then you are evaluating how they are transported to the surface. And then you come to the biosphere, and then you need to assess the biosphere and also make kind of evaluations how the biosphere is evolving during the 100,000 years or something like that. And then you come to the actual dose, how the people are, if they are having water or eating something, and then you have radionuclides inside you, and then you come to the actual effect. And then you try to evaluate the risk. So it's quite complicated and really comprehensive. But this needs to be done. It's quite a lot of work, but this needs to be done. But then I would maybe like to come back to what's challenging and what's the kind of challenge. And I think my points are exactly like you said, that we have the disposal solutions exist. I would say that. Coming from the regulator, of course. So from that perspective, but we have evaluated POSIVA's safety demonstration a couple of times. Latest comprehensively in construction license phase. Safety is demonstrated. This hasn't been a big problem in Finland, but in many countries it's really difficult to have the disposal projects moving on. I think then we come to the stakeholder confidence, political confidence, trust to the different implementers or regulators. And I think in a way the challenge is about, I don't know if it's correct, but kind of risk communication dialogue, how we are communicating about the risks. It's for us experts, it's quite difficult to be general. There's always uncertainties, and we like to discuss about uncertainties, but it's not maybe building the trust. So of course we need to be open about that, but how to discuss and how to have the trust that disposal can be maintained. Or can be developed and maintained. And this is also, with Daniel, we are in the NEA, Radioactive Waste Management Committee, members of that. NEA has quite a lot of activities and groups, really. One really focusing on that, on the stakeholder confidence. Those that have been working with safety demonstration for a long time, I think they are more and more discussing about how to demonstrate and how to discuss or have the dialogue with the public and other stakeholders and decision makers. So it's how to gain the trust.
So you've mentioned a lot, you talked a lot about long-term safety, but to my mind there is also a challenge during operation, because it's the specificity of such facility is that it's a nuclear facility that's underground. So can you talk a bit more about the nuclear safety aspect during operation?
Yeah, of course that needs to be taken into account. And that's, I think it's partly discussed quite a lot, and I don't know if it's a challenge, but it's discussed because the waste management organization or the companies haven't been focusing on that. So it's in a way new thing for waste management community. But it's not a new thing for radioactive companies or for nuclear power plants or nuclear waste storages. They are doing fairly similar things all the time. They are handling waste, they are handling spent fuel safely. So we can learn about that and so on. The specificity is the underground, and then there is, for example, the fire, like in the French case that has been discussed a lot. That's one specificity underground, that the fire is a little bit different and how to manage that. But based on what POSIVA has been demonstrating and we have evaluated, it's really difficult to get any significant dose out of the facility, even into accident, because there is that kind of, it's physically quite hard, because there is no heat, you are not, there is no explosion, it just cracks open the canister and then the radionuclides are released. If you stop the ventilation and you have systems for that, almost nothing comes out. That's kind of demonstrated and evaluated, but still it is a topic that needs to be managed,
covered.
but I would say it's not that difficult.
Daniel, do you want to add something on that?
Yeah, well, in the French way, the Ardra has developed the project. During the first 15 years, we were mainly focused on long-term safety. How can we predict and project our certainties on a very long period of time? Then after that, we went to more engineering studies to design the facility. And after that, well, we integrate progressively operational safety. One specificity of CIGO project, this facility will be operated during 120 years approximately. So it's a very long operational process, and we also in CIGO we will construct the facility while we will operate other part of the facility. So we are mixing difficulties of having a construction activity and nuclear activity at 500 meters depth. So we got all this difficulty, and also in addition to that, and Jussi just introduced that we don't dispose spent fuel, we dispose of vitrified waste, and also intermediate level waste. For those type of waste, we have some specific requirements concerning operational safety, linked to the release of gases, to the fire risk, etc. So we got to integrate in our design measures to reduce and try to manage this fire risks. This is why we excluded all the tires and things like this from our equipments. So we did a lot just to reduce and just to be to convince that we are able to operate this facility, and this will be presented in our license application. For the surface part of the facility, well, the knowledge already exists. I mean, we don't open the waste packages. I mean, we are conditioning the waste packages, and based on the experience of the French main actors, we were able to integrate this way of doing the things inside the CGO. So, well, for the surface facility, it was quite easier. But for the underground facility, well, you bring all these difficulties of tunneling the repository, operating a part of the repository, and well, it is at 500 meters depth. So if you have a fire, this is a very significant risk.
Thank you. So we have discussed about the legal framework, the stakeholder involvement, safety on already existing facilities or projects. All this field of radioactive waste management is full of opportunities in terms of innovation, but also markets. And this is a message I would like particularly to deliver to the young generation. That there are a lot of things to do in this industry, in this particular field. And so we are going to go a bit more on the industrial aspect of it. So particularly regarding France, France has made the choice of reprocessing spent fuel, meaning with the objective of reducing its volume by a factor of 5 and its radiotoxicity by a factor of 10. So at the end, we have high-level waste conditioned in a glass matrix and uranium and plutonium recycled to manufacture new fuel assemblies. And such process has been implemented for more than 40 years, especially in Orano facilities at an industrial scale. So Jean-Michel, is there still a potential for innovation in this core business? And can this expertise be applied to other types of waste?
Yes, we have still opportunities of innovation. But you mentioned all the benefits of the recycling of the nuclear materials coming from the fuel assemblies. And just to give another figure, it's now 10% of the electricity in France which is produced from recycling material. And in the coming years, we intend to go up to 20% by the reuse of the uranium more intensively. And thus, we can say that now in France, the French nuclear industry has more than 40 years of experience in recycling, and we are a pioneering industry in circular economy. I think it's very important to mention that. But we must not be stopped there, especially about the waste management. for the waste management, we have still to increase our performance in reducing the volume, in reducing the toxicity, and especially to avoid at the end the deep disposal of this waste. It's very important to work on that. Just to mention two examples of development we were performing, we are working especially about the metallic waste. The metallic waste, are currently compacted, and then they must be sent to CGO, to the deep disposal in France. But we could also decategorize them. It means we could remove the last traces of fissile material, of minor actinides, or of fission product, to be able to, at the end, dispose them in a surface disposal. Thus, we are developing new technologies for that, which are able to remove the radioactive elements from the zirconium. The zirconium is the metallic that we use, the metal, that we use for these fuel assemblies, for the manufacturing of the fuel assemblies. And at the end, we will be able also to reuse the zirconium for another purpose, and it's another example of a circular economy that we develop. But more generally, we intend to develop technologies to reduce the lifetime of the waste in order to achieve a lifetime lower than 300 years. It means, at the end, to be able to store, to dispose all the waste to a surface disposal. And this is consistent with the strategic contract, the French strategic contract we have in the nuclear industry. We are going to develop dedicated reactors for that, especially the molten salt reactors, which are able to transmute the minor actinides and all the other fissile material that we have, to be able to remove the radioactivity, the high radioactivity from the waste. And this is also consistent with the development that we have in France of the small modular reactors. That's all that is included in the French policy that we're developing.
Maybe to follow up regarding this industry of recycling and the specific know-how, what are the market perspectives in France or abroad for such technologies, services?
In France, we are going to start with that. In France, the closed cycle, as we say, the recycling of material and the waste management in that way, was reassessed in France as a strategic asset for France, and is mentioned like that in the multi-annual strategic plan for the energy in France. And thus we have decided to reinforce, to strengthen the recycling of fissile of material. Thus, currently, the recycling of material by manufacturing MOX is only the MOX fuel assemblies are only loaded in the 12-feet reactors in France, and we are going to load these MOX fuel assemblies now in the future in the 14-feet reactors, and with the intention to load the first lead test assembly in 2024. That's the first action in the short term. Mm-hmm. In the longer term, we are going also to develop what we call the multi-recycling. Multi-recycling is the recycling of the MOX paint fuel. That's a second round for the recycling, and more recycling if we can. We have already this experience in France by recycling MOX paint fuel for foreign customers, especially in Orano, but we are going to develop that multi-recycling for the French fleet. That means that we have to industrialize that, and we are going to have a specific research and development program for that. And we intend also to load a multi-recycled fuel assembly in a lead test reactor in 2027, 2028. Afterwards, EDF will be able to decide if it's possible to industrialize completely that route of management. And in that way, if we are going in this way, at the end, that could be more than 30% of nuclear energy in France, which is produced with recycled materials. That's in France. Maybe for other countries, just a few examples. In Japan, as you know, they have nuclear reactors that they have to restart completely. They need to have in their plan about 30 reactors in operation in 2030, and in that plan, they maintain also the closed cycle, thus the recycling of the material with the manufacturing of MOX fuel, and they added also that the reduction of the plutonium stockpile for their strategy. And that was the first time in 15 years that the Japan Atomic Energy Commission revised the guidelines of its strategy to reduce that plutonium use, to reduce the stockpile, of plutonium. Another example is China. China is developing, as everybody knows, a lot of reactors. They have currently 50 reactors in operation. They have a plan to build more than 30 reactors in addition. And China has confirmed also that the closed cycle is the way to manage the fuel assemblies, the fuel for the future, and it's also a part of the strategic plan. And for both countries, I think that the French experience can be valued as well to develop their activity in those countries. And just a last example, in Europe, you have, in Netherlands, it's a small country, as we say. It's a small country for the nuclear energy. They have a few reactors, but they have also a pragmatic approach from a technical and economical point of view, because they decided for a long time that they have also use a closed cycle that they use the MOX fuel in their reactors, and they intend to pursue in that way in the future, despite the fact that they don't have any fuel cycle installation in their own territory. Thus they use other installation, especially the French installation in The Hague.
Thank you very much. So EDF is responsible for the management of the waste produced during operation, but also related to the decommissioning of its power plants. From your point of view, what are the innovation potential of this business and along the entire chain value?
Yes, EDF, in fact, has chosen to turn this legal requirement in an asset, and then EDF is developing the skills and the industrial tools to create an industrial sector for dismantling and waste management. An example of EDF commitment in waste management is the commissioning of new facilities. A few days ago, on November 18, EDF inaugurated ICEDA. ICEDA is the EDF global solution to package and to store intermediate level long life metallic waste coming from operating activities and also from dismantling operations. This facility is now fully operational and has begun its first packaging campaign. Another example is a Technosan project, a facility for recycling metal, which is led by EDF in partnership with Orano, and which could be built at Fessenheim. The objective is to produce, after melting, ingots with characteristics, radiological characteristics, guarantee that they have no impact on health or environment, whatever they use. For that, you need an evolution of French regulation, but in the fact, this evolution is engaged in order to allow recycling metals. as it is done in the other European countries after treatment and control. And so in France, in the coming decades, approximately 500,000 tons of metal, very low level metallic waste will be produced with the future dismantling of nuclear facilities. And so Technosound project will represent an alternative solution to the final disposal of a large quantities of recoverable metals. And I will finish with another example of EDF commitment in waste management. That's the fact that EDF has created several subsidiaries, bringing together in Cyclife engineering teams and industrial waste management tools in France, but also in Europe.
This is a good example, but maybe even Jean-Michel and Olivier, you can explain a bit more. What do you do as an industrial to foster such innovation? So you've mentioned multi-recycling, you've mentioned this new facility with ICEDA, but also the fact that you have this new subsidiary with Cyclife. So how do you foster this innovation and the new industrial tools?
I think for the French nuclear industry, we are working together. That's here you have EDF, you have Orano, but you have also the CEA, you have also all the GFN members of the company which are in the GFN, the cooperation of the different nuclear companies. I think it's very important to work not only within operators, but also with all the startups and all the different small companies which can have a lot of ideas. And in France, we try to develop that. It's not easy because it's nuclear activity. Historically, that was an activity which was dedicated only to engineers with a lot of formation and so on, a lot of training. But now we try to find new ideas coming from the conventional industry and to be reused for the nuclear industry and to go faster to develop new technologies. I think it's very important to activate all the network that we have in France with a lot of ideas. I say in France, but sometimes we have also good ideas abroad, and if this is the case, we can use them also. But it's very important not to be only in our art of activity, but to open our eyes to find very innovative solutions without any a priori.
Especially innovation that were developed for other industries that you bring
we can use and can bring for the nuclear industry. We can say to nuclearize them, but it's maybe better that to start from the beginning and to develop a complete new technology.
Yes, I would add that in fact we work on innovation via partnerships. And yesterday we announced the creation of a new subsidiary with Veolia, Waste to Glass. It was in WNE, and it's an example of partnership. And the objective is to develop new solution based on vitrification that could allow acceptance of special waste in a final repository. So it's an example for how we work on the innovation on waste management.
And maybe, Olivier, you can give your views on the market perspective in France and worldwide based on your core business at EDF.
Yes, you're right, based on business, because concerning waste management and dismantling, the priority of EDF is to develop a solution for its own needs. and then we look around, and the prospect are the other nuclear operators that could have similar needs. And then our market is the direct consequence of our assets. And so I've spoken about waste to glass, but we also have other assets. We rely on Cyclife France, Cyclife UK, Cyclife Sweden, who operate industrial tools based on incineration and melting technology, and that make possible to considerably limit the volume of waste in final repository. We also developed, I've mentioned subsidiaries, engineering subsidiaries, so I will talk about that. Cyclife Engineering, Graphitech, and Cyclife Digital Solution. They are bringing solutions to optimize technical dismantling process. An example linked to innovation of what is expected in this field is robotic solutions that can bring a significant contribution to control and to optimize numerous and repetitive operations. And in addition, the integration of artificial intelligence solution can bring contribution to place the tool to save time. And that's a field on which we work with Graphitech for the graphite reactors. And another example we address to Cyclife Digital Solution is the use of digital simulations to prepare and to optimize dismantling operations to obtain scenario cost or dosimetry, waste flows, lead times, and at the scale of elementary operation or in a more systemic way to optimize global dismantling and waste management sequences.
And are these solutions already implemented for your own project, or it's starting step by steps?
Yes, both. Because, for example, for graphite reactors, we are implementing this solution now with Graphitech, and we are working on testing them with a new installation before implementing them on the real reactors. So they are already real, but still in progress.
Okay, thank you. I think something very interesting you mentioned is the fact that sometimes industrial innovation makes some move towards a new regulation or changes in regulation. Do you have other example abroad of such changes? To answer innovation needs, we need to move and change the regulation, and so there needs to be communication with the regulatory, which is different from the usual licensing process.
Yeah, I think that's a good question, and that comes to also in a way little bit more broader to the regulator role and how the regulator is part of the system or the industry, not the industry, but the nuclear overall. I was thinking of some examples, but maybe not really so concrete, but maybe what we have been discussing in NEA, for example, is the robotics and if or artificial intelligence is a little bit further away, but then we come to the kind of in the discussions who is making the decisions and how the judgment is kind of developed, and can you understand it similarly as you did it before? So how you can demonstrate that the regulator and how we can evaluate that. But that's more about maybe for the future. But of course there is new things that regulations and regulators are developed during the history of the industry, and our regulations are based on how it has been or what has been seen needed. And if new innovative things are needed, then I think it might need the change in regulations. And I think just from my perspective, it's really good if the industry opens to discussions early on, so that we can learn. There is one part the regulator has to learn, and then it takes a little bit time to change the regulations or develop new, so we can start. But we need to have knowledge, and then we need to have some time, and then we need to have the dialogue with the industry. That is this a good requirement, or is this narrowing too much, or something like that? So then it's about the dialogue, and in the end we would have a good regulation.
Do you want to add something on? Maybe I can formulate the question differently. It would be like, for example, new technologies brings innovation to a field which is nuclear waste management that can appear to be a bit formal and rigid. And does that help communicating about this field to the regulatory, or even to the public and the locals?
Yeah, absolutely. So, I mean, even in the field of nuclear waste, which has really been sort of a top-down kind of government-controlled pursuit, there is private sector innovation. There's a company called Deep Isolation, which is developing fascinating technology for deep borehole disposal of nuclear waste, which is very promising technology. I think one of the things that the governments can do is to unleash that private sector innovation so that they can bring that innovation to managing nuclear waste. I think that even though the government necessarily needs to be involved, I mean, there's no way of managing nuclear waste without government involvement, but at the same time, I think you need to employ the dynamism of the private sector to keep things moving, because we've also seen that, that these projects can be extremely slow, and that slowness, I think, hurts the credibility of our eventual ability to manage it. I just take one example. There is, in Connecticut, a decommissioned nuclear power plant, which all that is left of the once operating power plant is a pad about the size of this stage with the used fuel in casks, waiting to be moved to some final location. Other than that, the entire site has been returned to woods, pristine green woods along the river. And so once they do something with that used nuclear fuel, the communities, the state will say, okay, nuclear has shown the responsibility that they know how to manage the end of life. And that's what we're waiting for. And I think once we can demonstrate that, I think it'll help boost that growth that we're all looking for that I mentioned earlier.
Thank you. To boost innovation in the field of waste management, and especially nuclear waste management, France has set up investment plans to financially support research. Daniel, can you comment on this mechanism and maybe how industrial inputs are embedded that innovation dynamic?
Yes, well, and this is a very nice transition. Well, yes, the private sector can contribute to our innovation. I mean, they can bring new ideas that are, well, we are not familiar with that. They can bring some ruptures. But in any case, Andra, we are the Radioactive Waste Management Agency, so what they are performing on the waste material, it's not really in our scope. But, well, nevertheless, 6 years ago, it was decided in France to launch what we call the Plan for les investissements d'avenir, so future investment plan. And the idea, and focus on radiological waste. The idea was, well, when Andra is an operator of disposal facility. In fact, what we are operating is a volume. And we have to operate a volume, safety, and with a value for the money. So this volume is very rare. It has to be kept for the right purpose. And in parallel to that, France was launching many programs on dismantling of laboratories, nuclear installations, and the volume, and we don't have clearance in France. We don't have clearance level. So all this waste, these materials are basically considered as waste. And this could be a link to the regulation. The French regulation may evolve in the future to allow that, well, some of the waste, first, we can reduce the dangerousness of this waste by recycling, reusing, and there are a lot of work in Orano, in EDF on this topic, but also it can come from more academic for the private sector, which can be very innovative. And so this plan for investment for the future was to accompany this innovation, to bring them to improve the ideas, to try to issue prototypes, etc., and try to go up in the tier technology readiness level to get sure that, well, this could one day be included in the waste stream. So there was this plan for the investment for the future, and so Andra was the organizer of this. And so we are accompanying 39 innovative projects, while we do mainly the project management and the organization, and we try to coordinate and to facilitate the work with those contractors.
Thank you.
So innovation is really in the heart of our activity, because there is a need. We have to save place. We have to dispose of the right waste.
Well, thank you very much. I suggest that to conclude, each of you kind of give a few words of, for you, the challenges or the main message about nuclear waste management related to what we've talked about, your topics, and maybe Jean-Michel, you can start.
Yes, to conclude, yes, we know that now nuclear energy is recognized as a solution against the climate change. We have also said that we have developed in the nuclear energy, especially in France, the circular economy for decades. But waste management remains one of the major stakes to convince the last people who are still skeptical versus the nuclear energy. And thus the challenge is to still to progress in the management of the waste, especially by achieving the deep disposal. That's our responsibility to dispose of the waste from the past, from the former generation, and our generation is really our responsibility, and we have to finalize that project of disposal in France to close the loop, as we say, but also to develop new reactors, especially to reduce the lifetime, as I said. At the end, we hope that we will avoid the deep disposal, but it's still necessary for the current, for the actual waste that we have to manage. But it means also to develop the modularity of the fuel cycle installation, to be able to and to give the flexibility to the industrial and political decision in link with the deployment of the future strategy for the nuclear capacity in France or abroad. Thus, the capability to integrate the new technologies progressively, because we cannot change immediately. We have still to produce and to guarantee the supply of the nuclear energy in France, and the capability to take into account the diversity of the future reactor, especially for the fuel manufacturing or the reprocessing of them. And I think it's very important. And if I can conclude only on one major stake, I think, is to reduce the duration of our project development. Takes a very long time in France, especially, but in the world also, it takes decades to achieve the objectives that we defined at the beginning of the project. We have to reduce that, and at the end, I think that we will demonstrate that nuclear energy is also a very innovating energy.
Thank you. Maybe Olivier and Daniel, you can follow up to
Yes, I have a
French chapter.
roughly a similar conclusion because, of course, we have the climate change. We want to more and more stakeholders are considering nuclear as a must-have, and waste management is still the major concern for population. We can see European taxonomy debates, for example, or polls, and I think that our biggest challenge is to raise awareness on all the action implemented on waste management, and make people understand that we can handle, that we do handle waste in a safe way with no impact on health and environment. Today, with ICEDA, 100% of waste produced by EDF PW reactors have a safe industrial solution. And so it's not only discussing about the future for repository. Today, waste have solutions. They have no impact on health and on environment, and it's very important to say that and to make people realize that it's already operational.
Thank you.
I fully agree with that. Well, in France, since we launched this nuclear program, this is quite significant nuclear program, we have to share that 3/3 of the volume of the waste that has been produced during all this long period, they are already disposed safely. They are in an Andras facility, so they are already disposed. So and the rest is perfectly stored safely in the operator facilities. So the waste, well, we have to share that the fact we have solution to manage safely the waste. We have solution to optimize the final life of this waste, let's say, and one of the things we are moving on is, okay, there are still room for innovation to reduce that burden for our generation, but also for next generation. And innovation will be a key element of the future of these activities.
Maybe just in a few words to conclude.
To keep it short, I agree. Now, when we are discussing here about the role of nuclear energy in the climate evolution, I think just keep in mind that you need to have also the safe waste management solution, and like we are discussing here. And if you want, we have in Finland good examples and good experiences, and we are happy to share about how we have been doing this. So that's a kind of invitation to come to discuss with us.
Thank you very much. Jared, do you want to add something very short?
Yes, very quickly, I just wanted to say, to recap, to make progress on nuclear waste, you need to engage your host communities, you need to unleash private sector innovation, and you need to change the incentives to make progress. And once we demonstrate that progress, it'll facilitate the growth in nuclear that we all want and need. So thank you.
Thank you, everyone, and I hope that you really enjoyed our discussions.